I am so happy to be here today. And again, we have two great speakers. And I think today, if you were in the Hulu presentation, you saw that people said, well, we expect TV to basically be the same as streaming. And so streaming and TV, the same, but different. Realistically, if you want good, you have to have a human look at every clip. And that we know is not possible. So these guys today, we've done a study. Akamai has done what does good look like, and we're going to jump in and figure out why this is important. So let's start off here. And Thomas, we have your white paper. So why did Akamai create this paper?
Yeah, so obviously Akamai, as one of the leading CDNs in video delivery, needs to look what challenges are out there talking about delivering a good quality to the end users. And secondly, there is a big transition happening from traditional broadcast over to OTT in all the areas. And we need to make sure that for our customers, this transition is happening as robust as possible. And also, we at least match the quality that the viewership is used to from traditional TV. So what we did is we tried to figure out what kind of impact quality really has on the audience and on the business, and secondly, it's really all around what is actually influencing the quality level. So what's the key factors that we need to think of when we want to determine what good looks like? And this is going from encoding letters over to different content genres, how to handle those kind of differences we have, as well as the player technology and network types.
Okay, so now you've talked about a couple of different things. Why don't we just look into a little bit about what the correlation is between good and the consumer experience?
Yeah, I mean, the overall objective for every business is, I think we heard that in the keynote from Hulu today as well, is like we want to keep the viewer and we want to keep them longer on our platform. There is one of the most important things is if the users are happy, they stay and they consume the content on the platform. But on the other hand, if we screw it up due to technical difficulties, they will leave. And as soon as they leave our service, it's not just almost close to impossible to get them back. It's also a really cost-extensive exercise to do so. So it's really important to take that into consideration. The other thing is, and this is one of the things that we likely forget about doing our work day in, day out, is that there are people out there that used to produce that content. And when they produce that content, they have a certain idea behind the scenes. So they want to keep the end viewer engaged with a piece of content. They want to have a really hard engagement and a really, really intensive moment for the viewer. And then they want to have them in a situation where they are a bit more calm back, just to push it up in the next moment. So it's really about telling the story and making that story available also through the pictures. And what happens, and those graphs are showing that, and we can talk about that more if you like, is that as soon as you serve users low quality, it has an immediate impact on the engagement. What we did is we used galvanic skin responses and facial coding techniques to determine what emotional feelings or what kind of emotions have been triggered and what not. And especially when having low quality, you see a drop in positive emotions like happiness and surprise and things like that. And you have a big increase in negative emotions like frustration and sadness. So it has a direct correlation between those two.
In fact, so we see here that the minute the degradation happens, surprise is the biggest emotion, and then the lack of happiness is the next emotion. And obviously, you don't want your customers having a lack of happiness. I think it's often a surprise that these are the kinds of statistics that come up from this. But right now in this report, Akamai settled on SSIMWAVE. And you went with a measurement, which is something that will determine how the good quality is. Right now, Dr. Wang, you won an Emmy Award for SIM, and they call you the professor of prime time. if I'm not mistaken. So the SIM Plus, which is the latest version of your work, has a number of things that you do to measure quality assurance, and you've overcome some of the other competitors in the market. Can you explain to me what it is that you're doing?
Basically, we have been working on this field in the past like 20 years. Because in the end, what matters is the final user's experience. That's what matters. And the whole video distribution system should be optimized for that. And Thomas has been talking about how these QoE is somehow related to user engagement, emotion, and all that. And of course, the first question is how you can measure that. And then you can talk about optimize that. So what we do is basically predict how humans assess video quality. So basically what you do is to put the human visual system into a software that just like behave like a human brain, and how we can get as close to that as possible. So of course, this involves a lot of research on how the human visual system behave, and also you can still get so. And also we want this measurement to be adapted to the real world, because in the real world you have videos of different resolutions, different devices. And say, for example, for the same video, if you watch that on a cell phone or on a TV, you're going to get different experiences. And then you want to be able to predict that. Only when you have human eyes watching those videos, you can predict that. And our goal is to predict, use an algorithm to do that automatically. So this actually gives you a little bit example, right? So a little bit deep dive into what's exactly happening in that algorithm. So on the left-hand side, you got the encoded video. Hopefully you can still see the video very clearly. And the right-hand side is the original video frame. And then perhaps a lot of the people in the audience, you can see the blocking artifacts in the sky kind of thing. So you want something to see that and immediately point out, oh, there are some problem with that video quality. If you go to the next slide, that actually gives you a per pixel level quality map. You see in the sky, you got all these blocking artifacts. Here, darker means worse quality. So basically, it helps you to pick up the problem with the video up to the pixel level. Right, so that's this is just give you a bit of flavor about what's happening inside the algorithm. Of course, the whole algorithm is computing a lot of other things about human visual perception, modeling, and so on. And this gives you some clue about what we can do in that algorithm. So actually, this gives you some more examples. So for example, we're going to give you a score between 0 to 100, predicting how humans would say about the video quality. So between 80 to 100 is excellent quality, between 60 to 80 is good quality, and so on, right? So of course, the worst quality between 0 and 20. And this actually gives you some example. This is the video quality at different quality level. When you get the quality score low, in this case 35, you can see kind of clear artifacts in that video frame. You can go even lower, actually. So that gives you terrible quality when you get a quality score 15. The thing is, you want to compute this in real time, very lightweight on a large-scale network. Actually, we can do this on thousands of channels and 24/7. Keep computing all these scores if you have live channels. Sending these videos out. So that's the capability behind the algorithm. So once you have something like this, so then you can talk about, I'm in control of the final viewer's QoE, because you can do all this measurement at different delivery points over the whole video distribution system. You can compare the scores across. And then you can say, okay, I can dial up the quality. If this particular content or this particular group of viewers, they're super important, I'm making money out of that, so I want to dial up the quality. And at the same time, for other content, maybe you can dial down a little bit and to save you a lot of resource, a lot of bandwidth, and so on. So then you can talk about I'm fully in control of user QoE.
Okay, so this score does make sense, and you can definitely see the differences between the images. In fact, I read that the 80 is considered a good HD TV score. So realistically, when you have this knowledge and people have the ability to tune up or tune down, that means that they also have control of their costs, right?
Yeah, that's right, exactly. Yeah.
Okay, the cost, the data, and that's,
Right,
of course,
right.
going to bring us to Thomas. So Thomas, so you've got the findings here from Akamai, and what were the kind of the overarching things that you've found from this report?
Yeah, so one of the most important things absolutely is like using such a score and such an opportunity to really measure what the quality does look like on the different different factors and variables that you're using, like content genre and bitrate profile and network and especially device, gives you a first insight into what actually is needed to deliver a quality, and the differences, and we will see that later on, are kind of tremendous between the different devices and content genres especially. So one of the key takeaways is absolutely it affects the bottom line. It has a direct impact on your customers, and if you succeed on delivering a good quality, you will have immediate impact on your churn rate and the overall success of your platform. The second one is, as soon as we talk about quality, we most likely need to stop talking about just buffering and when it comes to end users. It's really more about the evidence KPIs. So what kind of impact do we have? What kind of impact does different variables have on the overall flow? So for example, take the device set. Sending out an HD-like signal where you want to hit a score of 80 with SSIM Plus, for example, to an 55-inch screen, you would need something like 6 to 8 megabits per second to do that with a standard technology, standard encoding technology being used out today. I'm not talking about new codecs. It's H.264, which is still dominant on the market. But on for the same piece of content, which is a hard to encode piece of content, you only need like 3 to 4 megabits per second for a mobile device. Because after that, you do not see a material impact on the perceived quality for an end user on the same piece of content. If you take a look at the report later on, you will find those results that are describing the different content genres and different technologies. And last but not least, it's not always about the CDN that can introduce challenges to that overall delivery of quality.
So, in fact, you mentioned that there's different KPIs, and it's also a question of when you have content, it may not be the CDN. So why is that? So, I mean, and obviously you're Akamai.
Obviously I'm Akamai.
But you still have this interesting perspective on how the kind of the newer focus is for the quality measurement. So give me a bit of background on that.
Yeah, as just mentioned, just take the example of the bit rates for a hard to encode complex content scenario. What we see still a lot of time is that the same manifest with all the different bitrate profiles is being handed out to every single device in the value chain, just because it's easy and it's easy to put out. But being smart about where we send what data and what kind of bitrate letters is really important. We should make the bitrate letters better instead of just more and blow them up. And I think that's one of the key importance. We need to be smart about which device, which network condition, and what content genre we want to really present.
So you talked a little bit earlier about the differences in file sizes between 4K and 8K. So what's the long-range kind of implications for content distribution when it looks like you have a quality score and you have the different needs for supporting 4K, 8K, and HDR? What is it that's important for people to think about when it comes to the quality score?
Yeah, it's. I think there's two aspects to that. One is the technology part. So if we want to talk about 4K and take a good megabits per second profile for an HD, we need to quadruple that, staying on the same codec. Obviously, there are efficiency ways of using other codecs, but still for 4K content, you are looking for something like 12 to 15 megabits per second, which is a huge difference. We talked about being smart and being also cost efficient when delivering the content. I think I'm a big fan of not just increasing the number of pixels, but making the pixels better that we have. So looking at something like HDR, which has a huge impact, and you might you might not need it to look at if the customers are really willing to pay more for a 4K experience, for example, because it will just cost more money to deliver.
Okay. So that's actually the end of our presentation, but we have time for questions, and I've got probably a couple of things to say just before we hit the questions. It sounds like the ability to measure is going to give us a chance to tune up, tune down the quality, and also look at what we're spending in terms of data delivery. So that's definitely one thing. What about in the audience? Does anybody else have a question? There's a gentleman.
Right.
Troy's going to actually walk around with a mic. The man right here,
Yes.
and we can ask.
Here we go.
So on the Netflix video engineering blog, they talk about VMAF, which is a way to measure video quality, and then use that as a mechanism to look at the source quality and the encoded quality to do per title, per scene encoding to optimize the encoder output quality for different bit rates and different scenes. And if I'm using something like that, if I'm using a per title encode technology like they talk about in their blog, where does a tool like this, like SSIMWAVE, sit in the workflow from glass to glass if I'm already using an encoder that's kind of quality aware in a per title mechanism? Where would it fit in the workflow, and then what metrics would it provide that I could use to optimize something further down?
So Netflix really helped the industry to promote the industry about caring about QoE, right? So we should really compute QoE and use QoE to control our video distribution. So at this point, this open source project, I think, is still at the stage of more like a lab use kind of case, and then rather like SSIMWAVE is already like enterprise solution, and is SSIMWAVE is already running like thousands of live channels 24/7, and it's really real time, and they can compare videos across resolution. So for example, if you have video that's coming in and do transcoding to different resolution and different bit rate, the input-output video, when you compare them, they don't even have the same resolution. How you can handle those kind of situations, how you can do all of these in real time. And and also the cross-device properties, at this point, VMAF is not working that well yet. So if you really look at the scores and cross-resolution, VMAF is able to compute some scores for different resolutions, but at this point, it's really hard for you to compare the score across different resolutions. If you don't have those kind of properties, those kind of things very well aligned, it's really still hard for you to make decision. I should go to this resolution or the other resolution. This is going to have impact on how much impact on this device or the other device. Like SSIMWAVE has a unified human visual system based model, and it can compute the scores for hundreds of thousands of devices depending on the device parameters. So it's already at that mature stage, and it's already designed for operation already. So that's the current difference at this point.
Okay, do we have any more time left? How are we doing for time?
Yeah, we got a couple minutes.
Okay. So
You want to follow up here? Sure.
Just a question. So both technologies are used at the input and output of the encoder. Do you see it used anywhere else in the workflow, though?
Oh, actually, by the way, I didn't mention that the SSIMWAVE also has like checking your source encode, source input. You have input. Sometimes you got crappy video as your source, and you have to detect that. And SSIMWAVE is also doing this final at the end as user device. You can pour out an HDMI output that's supposed to go to the TV. You can measure the quality up to that point as well. So, and all the scores are consistent over the whole video delivery chain. That gives you a really, really massive understanding about what's going on in your video distribution. It's not at the post-transcoder point. Right.
So it's essentially you can measure the HDMI out.
Yeah, that's right.
Okay,
Yeah.
all right.
Okay.
And
one more.
Just
here.
maybe to
One more
add,
question.
just add one sentence here.
Sure.
One of the reasons why we picked SSIM for our study is it's independent. You are not relied to something like Netflix or someone like Netflix changing something that will change the whole way of the results.
Okay, one last question.
So SSIM is based on structural similarity. So it sounds like your score here is not based on that concept of comparing the original to the encoded version. It's based on a human visual model. Is that correct?
So that's a very good question. So structural similarity is something a paper I published in 2004. Now it's already 15 years after that. So we have done a lot of more research on top of that. I'm a still professor actually at the University of Waterloo. We have a research team dedicated to this research. And over the 15 years, we have done a lot of things on top of that. So you can think about structural similarity as SSIM as a starting point, is general philosophy, but there are so many things have been added on top of that. So it's much more advanced. Actually, I have another talk at 4:30 today. I'm going to go a little bit deeper, how you make a difference from structural similarity to Sim+. So we're going to have more time to talk about that. Yeah.
So can you also use machine learning and AI to improve your algorithm here?
Yeah, we did. We already did that. So yeah, that's a good thing. That's a good question. So
Okay.
Okay, so we've got another talk later. We've got, so Akamai is going to email their report to people, and Troy has got the key things, which are the names.
Well, before we get there, I think Nadine, Zhou, and Thomas did a fantastic job. Round of applause.
Thank you.